Good evening, all.
Good evening, sir.
Audio visual clear.
Yes, sir.
Yes, sir.
Okay. So we are in unit number three, grain-based fermentation. Grain-based fermentation. We till now covered idli dosa manufacturing process, bread and tempeh. The last manufacturing process, or last fermented product, grain-based. Under it is soya sauce. So today's class all about soya sauce, manufacturing process, principle of soya sauce making, as well as we also covered the spoilage of the grain-based product. Okay, so start with the soya sauce manufacturing process. What is soya sauce? First of all, soya sauce is a dark brown liquid made from a mixture of soybean and wheat. So in this statement clearly mentioned the raw materials of the soya sauce manufacturing process, and the raw materials are soybean and wheat. So out of soybean wheat, manufacturing steps, different manufacturing steps produce soya sauce, which is dark and brown color, dark and not dark brown color. And how does the brown color is obtained? We go into the manufacturing process and see how does this dark brown color is obtained. It is during the manufacturing steps, it is during the fermentation steps. And by the fermentation process, this dark brown is obtained. Clear? And also mention that soya sauce is natural fermented product. Natural fermentation product means no starter culture needed for the manufacture of soya sauce. Just আমরা use করব হচ্ছে raw materials, proper condition, fermentation process, and it will be done. So it is a natural fermented product. Do not need any addition of starter culture, specialized formulated starter culture. And maximum grain-based product, including idli dosa, they also do not need any starter culture. The indigenous microbes are enough to capable of fermented the products and produce the outcome of the final product, idli dosa like soya sauce also. But inside the bread and tempeh, starter culture has been added, special starter culture. So initial part clear. Now enter into the manufacturing steps.
স্যার বলছিলাম ব্রেডের ওই লিভনিং পোর্শনটা তো কমপ্লিট হয়নি স্যার।
Livening
লিভনিং
portion,
পোর্শন, হ্যাঁ।
মানে বুঝলাম না, লিভেনিং পোর্শন ইজ জাস্ট আ রিয়াকশন।
না মানে আমার কলেজে যে নোটস দেওয়া রয়েছে লিভনিং এর অনেকগুলো মানে 2-4টে পেজের নোটস আছে, তো ওটাই
একটু
আমি
চেক
জিজ্ঞেস করছি।
করাবে আমাকে দিয়ে, বুঝতে পারলাম না, একবার চেক করাবি, ঠিক আছে? আমি দেখে নেবো যে কোন জায়গাটা ওরা দিচ্ছে।
ঠিক আছে স্যার।
কলেজের নোটসটা একটু আমাকে পাঠাবে, তো আমি চেক করে দেখবো যে কোন জায়গাটা ওরা স্পেশালি দিচ্ছে, মানে লিসেনিং পোর্শনে। ঠিক
ওকে
আছে?
স্যার।
হ্যাঁ, যে জায়গাটা প্রবলেম হচ্ছে, নট ফুল নোটস, যে জায়গাটা প্রবলেম হচ্ছে, যে জায়গাটা দেখাবে মনে করছে, সেটা একবার দেখিয়ে নিও। ওকে, সো ম্যানুফ্যাকচারিং প্রসেস, first start with raw materials. Obviously, the raw materials, soybean, and number two, wheat. Fermenting organism. Natural fermenter, natural organism, fermenting organisms are involved to produce the soy sauce. Natural or indigenous, better to say indigenous microbes. And some examples of indigenous microbes involved in soy sauce manufacturing are fungi, bacteria, as well as yeast. Aspergillus oryzae. Aspergillus soje. These two fungi are involved in soy sauce manufacturing step. Aspergillus fungi, or you can say also mold. Okay, bacteria involved. Lactobacillus means lab group, lactic acid bacteria group, lactobacillus, delbrueckii, leuconostoc mesenteroids, and under yeast, some examples are Zygosaccharomyces, SOA, Zygosaccharomyces roxy. So these are some examples. They are all indigenous. They are not starter culture making. Made. It is indigenous microbes present in soybean and wheat. They are involved in production of soy sauce. So first raw materials done, fermenting
স্যার
organism done. হ্যাঁ,
স্যার
হ্যাঁ।
বলছি ওই ব্যাকটেরিয়ার ফার্স্টে ওটা কি লিখেছেন একটু বলবেন?
ব্যাকটেরিয়া ফার্স্ট হচ্ছে ল্যাক্টোব্যাসিলাস ডেলব্রুকি, DELBRUECKI,
আচ্ছা,
স্পিসিস নেম, জিনাস নেম হচ্ছে ল্যাক্টোব্যাসিলাস, সেকেন্ড ব্যাকটেরিয়া লিউকোনস্টক মেসেন্টেরয়েডস। Done.
Yeah, sir.
Manufacturing step point 3, raw material processing. After raw material selection, indigenous microbes they are involved. What are they involved? Knowing. Third step, raw material processing. All the raw materials, that means we have selected wheat as well as soybean, they are all dried condition, yes or no? They do not contain any water percentage is very low, yes or no? So for that raw materials can go for the fermentation, no, because it should be hydrated. The dried product contain less amount of water, and less amount of water cannot be fermented because it has very low quantity water, and this low quantity water cannot support the bacterial growth, microbial growth, fungal, mold, bacterial growth. That's why the first we have to choose the processing of the raw material. That means first soybean, wheat have to be soaked or some kinds of boiling done. That's why the water can incorporate into that, and now it is ready for the fermentation next step. Is it clear to all? As it is dried condition, so it need to be hydrated first. So processing of the raw materials here it is necessary task, and inside the processing, first soybean it is soaked for 16 hours. Then after that, steaming is done, steamed for 1 hour. On other side, wheat, the other raw material. First, wheat is roasted, then it is crushed. After crushing and soybean steaming, they are mixed together and cool at 25 degrees centigrade temperature. And this mixing is normally 1:1 ratio. So first you have to be done the raw materials processing step, and now it is ready for next fermentation process. This mixture now inoculated with the inoculation of Aspergillus oryzae or Aspergillus sojei. Mycraft. Who is Mycraft? Who is Mycraft? Hello. Who is Mycraft? Say your name. হঠাৎ করে কে জয়েন করলো?
Hello, sir. I am Saurabh.
হ্যাঁ, okay. It's too late. Okay, inoculation with Aspergillus oryzae or Aspergillus sojei. After that, step number 5. Incubate aerobically 28 to 30 degrees centigrade for 3 days. And after 3 days, the mold Aspergillus oryzae and Aspergillus sojei covered all the materials and form this structure is called koji. After 3 days, the structure where the molds are covered all the materials, and thus this structure is called koji. So short question can become what is koji? Huh? One mark question. What is koji? Koji means after inoculation with the Aspergillus oryzae and Aspergillus sojei or either or 28 to 30 degrees centigrade, 3 days, the whole products is covered with the molds, and that is called the koji. And koji is important because that 3 days, these organisms, these mold secreted various kinds of enzymes. So, importance of koji. What are the importance? Koji contain molds, Aspergillus oryzae or sojei. Koji containing molds secreted many enzymes, digestive enzymes actually, many enzymes like proteases, pectinases, amylases, etc. Proteinase, pectinase, they are protein digesting enzyme. Amylase is carbohydrate digesting enzyme. So that 3 days period, the moles secreted enzymes are actually mash this all the mixture because these enzymes soften all the things, degrade all the things, degrade the protein, degrade the carbohydrate, degrade the pectin content of this mixture and make it soft. So after 3 days, you get the mash-like structure. Like potato mash, it form a mash-like form. So next step, step number 6. Which is hydrated also. Hydrated also. In that state, mix koji with salt brine. Salt brine means it is a salt solution of 23% sodium chloride. Salt brine. What is salt brine? Salt brine means 20 to 25% salt water. And mainly the salt used here, sodium chloride. This mash is further softened with the addition of salt brine. And this structure is now, this formation is called moromi. M-O-R-O-M-I. So two short question. What is koji? What is moromi? It is the intermediate step in the soya sauce manufacturing process. Koji is after fermented with the molds Aspergillus oryzae or soje. And moromi হচ্ছে after addition of salt brine, the overall structure, the meshing structure further soften up and form moromi. Clear? And this term actually is an Asian specific term, na? And mainly soya sauce used in Asian specific countries. That's why these terms are koji, moromi, is like a Japanese Chinese term. Mainly used in the Asia countries. Okay, here is another point. Why salt brine is added? Importance of salt brine. Importance of salt. This high concentration salt has various roles. First role is restrict the growth of other organism. That means disease causing or spoilage causing organism. Restrict the growth of other organisms. And these organisms could be spoilage causing or disease causing. And another important role of the salt addition, high concentration, allow the grow of, only allow the growth of osmotolerant or halotolerant bacteria. Two terms are written over the board: osmotolerant, halotolerant. What does it mean? Osmotolerant, halotolerant both have the capacity to grow at high salt. High salt. And here the salt concentration is 25%. Huge concentration of salt brine is added inside the koji. So osmotolerant and halotolerant have the property to grow at high salt concentration. That's why it select this salt brine addition is very important. It select only to grow osmotolerant and halotolerant, and it reduces the growth of other microorganism, and these other microorganism could be spoilage causing, could be disease causing. So that is the restriction point. As it is the natural fermentation, that's why it should be restricted. Otherwise, many spoilage causing organism or disease causing organisms can grow inside the product of the fermented product, and it will be dangerous for our health also. Yes or no? And the shelf life of the product, if the spoilage causing organism grow more, then the shelf life of the product also reduces. So have to be restricted. And the restriction first point is this addition of high salt, and it should be added as it is a natural fermentation. If we start with the starter culture, then the addition of salt not necessary, right? Because only the starter cultures organisms are present inside the product. That's why do not need any kinds of salt, high concentration salt. But here it should need it. And we are also seeing in the cheese making the salt concentration is amount of salt concentration added in high. And the purpose of use high salt concentration in the cheese making is different, because it is required to large amount of water should be released, that is synergesis process ki induce করার জন্য, that is the separate scenario. But here salt concentration is added for checking the microbes, checking the spoilage causing microbes and disease causing microbes, and allow only That microbes which are able to grow at high salt concentration is osmotolerant and halotolerant microbes. Point clear? Online students.
Yes, sir.
Yes, sir.
So salt brine addition is critical for soy sauce making. Then number 7 point, step number 7. Now ferment the material. Normal temperature added. Normal temperature means 30 to 35 degrees centigrade, and 1 to 2 days. In that period of time, osmotolerant, halotolerant, lactic acid bacteria only grow. Osmotolerant, that period of time, osmotolerant, halotolerant, LAB, lactic acid bacteria can grow. And some microbes are involved, that is already written, Lactobacillus delbrueckii. This Lactobacillus delbrueckii is highly uh, salt resistant. And other salt tolerant yeast also can grow. Salt tolerant is like Zygosaccharomyces, Candida, etc. species can be grown. So fermentation complete. After fermentation, the next stage is pressing the materials, pressing the whole things, and it will separate the liquid and solid in two segments. So after that, step number 8, pressing. Soya sauce is the liquid part. The solid part has been discarded and the liquid part is needed for the bottling. So point 8, pressing. After pressing, two components produce, solid portion and the liquid portion. Solid portion discarded, which is not used, and the liquid portion used for further treatment. What do you think? What is the color of this liquid portion? What will be the color of this liquid portion? Is it brown color or it is just colorless? Slightly colored, but not that dark brown color. But dark brown color has to be achieved because it looks good. Soya sauce color has to be brown or dark brown. So this liquid portion after the fermentation is slightly brownish, but not that type of color which is outcome of the final product. So this liquid portion has to be used for the next treatment process, and that gives the color formation. And the process number 8, process number 9, temperature treatment, high temperature or pasteurization, better pasteurization. Pasteurization used for many purpose. Number one, pasteurization kill several organisms, spoilage causing. So it is the second check after the salt brine addition. The second check of the spoilage causing organism is the pasteurization. Pasteurization is high treatment of temperature. Treatment of temperature, that means 70 to 72 degrees centigrade used for the 30-minute, yes or no, pasteurization temperature time normal. 70 to 72 degrees centigrade used, and it is used for the 30 minutes. And this temperature, this 70 to 72 degrees centigrade temperature is important to enhance the color formation. So after this heat treatment during pasteurization, the color is achieved, means brown to dark brown. So what type of reaction is there? It is actually done by Maillard reaction. So pasteurization temperature induce Maillard reaction. What is Maillard reaction, sir? Maillard reaction is actually condensation of sugar with the amino acid and make the product which is colorful, brown color and etc. different color. So Maillard reaction need temperature which is provided by pasteurized temperature, and in Maillard temperature, Maillard reaction, sugars are combined as well as amino acids to form Maillard product, and this Maillard product give the color. What is this Maillard reaction? Maillard reaction means sugars combined and amino acid react with the amino acid to form Maillard product, and it needs for the combination and the reaction needs temperature, high temperature. 70-75 degree temperature is ideal for Maillard reaction, and it is provided by pasteurization, because pasteurization needs 70-72 degrees centigrade, and it is allowed for within 30 minutes, and this temperature time is important for Maillard reaction, and this Maillard reaction give the color of this versus ultimate color, final color.
স্যার সুগার গুলো অ্যামাইনো অ্যাসিডের সঙ্গে কম্বাইন করছে তো?
সুগার নিজেও কম্বাইন করে, অ্যামিনো অ্যাসিডের সাথে কম্বাইন করে। তো বোথ কম্বিনেশনের প্রোডাক্ট একটা লার্জ স্ট্রাকচার তৈরি হয়, দ্যাট ইজ কল্ড Maillard product, and Maillard product gives this color, pigmented. So importance of pasteurization is soy sauce. The first point is overall same, but second point is different from the milk. Yes or no? In milk there is no Maillard reaction. The purpose of pasteurization is different in milk, but pasteurization in soya sauce manufacturing stage, first point is same, second point is different. That is induces or enhance the color formation. Other purpose, number 3, acceleration of precipitation of protein, concentrate the flavor compound. So these are some usefulness of pasteurization in soya sauce making. After pasteurization, step number 10 is cooling, then bottling. Soya sauce done. Is it harmful for our health? Soya sauce consumption of soya sauce is harmful for health? Yes or no? Sometime. Which time? When you consume more. But low use could not make any difference. But when you use more, it could be harmful because of high salt concentration. High salt concentration, number one, it is harmful because when you consume more, salt concentration increase in your body and that increases your blood pressure. And blood pressure increase directly correlate with your heart health. That means cardiovascular disease are regulated by the heart blood pressure. So high salt concentration actually making the things worse. High salt concentration is needed, but it makes it worse for harmful or in our body. That is increase blood pressure and correlate with cardiovascular disease. Second harmfulness, the mold that is inoculated, aspergillus. These aspergillus have the capacity to produce toxin that is aflatoxin. And aflatoxin cannot damage at high temperature, pasteurized temperatures. Yes, aspergillus will be dead, but the toxin that release, it is not degraded. So toxin is alive inside the material, and this toxin could be harmful in our body. Eukaryotic cell, it can cause cancer. Carcinogenic property. Potent carcinogen. প্রবলেম হয়। হ্যাঁ, এবার আমি কি বললাম রেগুলেট ওয়েতে নাও। নরমালি সোয়া সস ভেরি লো অ্যামাউন্টে ইউজ হয় যখন তোমার চাইনিজ প্রোডাক্ট গুলো তৈরি হয়, স্লো কমই ইউজ হয়, খুব বেশি ইউজ হয় না। হ্যাঁ, এবার তুমি বোতল বোতল খেয়ে নিচ্ছ তাহলে তো প্রবলেম আসছে। মানে কম খাওয়া, রেগুলেটেড ওয়েতে কনজিউম করা ইম্পর্টেন্ট। হ্যাঁ, লো কোয়ালিটি তো আরো খারাপ, দ্যাট মিনস ফার্মেন্টেশন ঠিকঠাক রেগুলেটই হয়নি। It is that temperature, that time is not regulated. So chance of production is much more high aflatoxin, and chance of production salt concentration also high. So these two makes critical for your health. Any question? Soy sauce manufacturing step. From soy sauce manufacturing step, any question? All steps are good. এই দুটো point. High salt
Sir,
and the aflatoxin. Ah,
sir, could you explain Maillard reaction once more?
yes, Maillard reaction needed high temperature, and that temperature is given by the pasteurization, because pasteurization temperature is for 70 to 75 degrees centigrade at 30 minutes, and that temperature induces Maillard reaction. Maillard reaction actually combination of sugars and amino acids and make the Maillard product, which is pigmented and it is brown color. So ultimately the color of the products is rich in brown. So from the pale brown, it become dark brown at the end. So combination of sugar and amino acids.
Okay, sir.
So you can further question, sir, how does sugars and amino acids are come inside the product? Sugars and amino acid already present in the materials, but it is in the complex form. But after koji, that means fermented, the complex one is break down into simple one. So simple sugars are now ready for combination at high temperature. That give the Maillard reaction further enhanced.
Okay, sir.
After fermentation a simple sugar produced হয়েছে তো that time simple sugar means complex starch break down into glucose, fructose, etc. So these glucose, galactose, other sugars now combine each other at high temperature and Maillard reaction proceed. All clear?
Yes, sir.
So manufacturing products done grain based. Now we coming to the point of spoilage. Spoilage of grain based products. See, all the grain-based products like idli, dosa, bread, tempeh, and soy sauce. Except bread, all the products are non-perishable or semi-perishable. Can you explain what is perishable, semi-perishable, non-perishable product? It is also mentioned in the milk also. Milk spoilage. Perishable means highly nutrient rich and it could spoil within 1 day. That is perishable. No products here. Idli, dosa, tempeh, soya sauce, they are high shelf life. They can easily maintain their own integrity, cannot spoil easily. But bread, except bread, bread can spoil. So here in the scenario, so we first focus, mainly focus on bread. How does the bread spoil? Because other products cannot spoil easily. They are non-perishable or semi-perishable. So directly go into the point bread spoilage. And in the bread manufacturing step, we also mentioned that point. It is different from the other fermentation because In other fermentation, the shelf life increases, but after fermentation. And here in the scenario of bread, the shelf life is decreases. So bread spoilage is very common under the grain-based product. So mainly covered here bread spoilage. The main microorganism that grow inside the bread is mold. Mold is very common, most common, and most important cause of spoilage, bread spoilage. Some example of molds that induce the bread spoilage: rhizopus, aspergillus, penicillium. Second, rope formation. The flexibility of the product is lost and form rope-like structure. And this is done by bacteria, growth of bacteria, bacterial growth, bacterial spoilage, and the main culprit, bacillus. During rope formation, bacillus capsulated is capsulated, means capsule layer present, which is polysaccharide layer, and it tends to stick with the other microbes, other materials. Capsulated, and with that capsule, stick together, as well as bacillus release proteolytic enzyme. Proteolytic enzyme to hydrolyze the gluten, to hydrolyze the gluten. And gluten is important for given the flexibility. This gluten has been break down by the bacillus secreted enzymes, as well as bacteria. This bacteria has the capsule and try to combine each other to make this ropiness. So flexibility gone and rope formation done. Common spoilage in bread.
তাহলে ক্যাপসুল পার্টটা বুঝলাম না, আগে বোঝাবেন?
Capsule is the outer layer, bacterial outer layer. After the cell wall, there is another layer that's called capsule. Capsule is mainly polysaccharide. The capsular material contains polysaccharide, that means sugar. Basically, that is sugar. And sugar molecules are very sticky together. Has the stickiness? Yes or no? Sugar has the stickiness property, so it can stick with the
Yes,
another
sir.
bacteria, another material and make it clump. So ropiness হতে গেলে কি করতে হবে? Just idea পাবো কি করবে? ওরা একটা clump তৈরি হবে, rope like form করবে, and the flexibility that given by the gluten also has been degraded. The gluten is degraded by the secreting proteolytic enzyme.
Okay, sir.
Third spoilage type in bread, common type, red bread, color being changed, and it is also happened due to the growth of bacterial spoilage. And the main one, Serratia. They are red color pigment forming bacteria. They are red color pigment forming bacteria. Another common spoilage in bread, growth of yeast, and the spoilage name is chalky bread. Here white color chalk like spot. Formed over the bread. And it is due to growth of yeast like fungi. Example, endomycopsis, trichosporium, etc. So these four are common bread spoilage type. So spoilage done, chapter done, unit done. Non-perishable. So they have high shelf life. So do not spoil easily. And their raw material also non-perishable. ওখানে কি ছিল মিল্কের? মিল্ক ইজ হাইলি পেরিশেবল, দ্যাটস ওয়াই মিল্কের অনেকগুলো স্পয়েলেজ টাইপ বেরিয়েছে। এখানে তো র ম্যাটেরিয়াল নন পেরিশেবল, তো আলাদা করে এক্সেট্রা আর স্পয়েলেজ কিছু নেই। ব্রেড স্পয়েলেজ ইজ দ্য মেন হাইলাইটিং পয়েন্ট।
স্যার প্রথম ইস্টটা কি লিখেছেন?
এন্ডোমাইকপসিস স্পিসিস, MYCOPSIS। সেকেন্ডটা লিখেছি ট্রাইকোস্পোরিয়ান, TRICHOSPORION। Unit complete, notes given soon, and exam will conducted after that. ওটা আগে হবে, কোর আগে হবে, কোর পেপারটা আগে হবে। 3-4টে দেখা হয়েছে, তারপর দেখা হয়নি, 3জনকে পাঠিয়েছি, বাকিগুলো বাকি আছে। আজকেই দেখতাম, দেখতে দেখতে হঠাৎ একটা কাজ হলো, উঠে চলে গেলাম, আর দেখা হলো না। বাট এক্সাম যা দেখেছি 3-4টে খাতা ভালো হয়নি। পড়ছো না বাড়িতে? ক্লাসে ক্লাস ওয়ার্কটা ঠিক করে করো, আর বাড়িতে যে নোটসটা পাচ্ছ সেটা পড়ো। লিখতে পারছো না ঠিক করে। এখনো তোমার 3-4টে এক্সামের পরও সেম প্রবলেম দাঁড়িয়ে যাচ্ছে, কনসলিডেট আনসার আসছে না আমার কাছে। কনসলিডেট আনসার 3টে খাতা কোথায় রেখেছি, 3জনকে পাঠিয়েছি, বিদিশাকে পাঠিয়েছি, জাহ্নবীকে পাঠিয়েছি আর শ্রেয়সীকে পাঠিয়েছি। 3টে খাতা দেখা হয়েছে এবং সেম ইস্যু। তোমার কনসলিডেশন আনসার নেই, মানে একদম কম্প্যাক্ট আনসার যেখান থেকে আমি নাম্বার কাটবো জায়গা পাবো না, সেই আনসার এখনো আসছে না। যদিও ইমপ্রুভমেন্ট হয়েছে, একদম ফার্স্টে যা এক্সাম দিচ্ছ তার থেকে অনেক ইমপ্রুভমেন্ট হয়েছে, বাট স্টিল দরকার আছে এখন ইমপ্রুভমেন্টের।
স্যার আপনি আমাকে এখনো পাঠাননি।
না, শ্রেয়সী আর একজন আছে, শ্রেয়সী সাহা, ওকে পাঠিয়েছি।
ও আচ্ছা
আমার
স্যার।
তুমি তো বিশ্বাস, হ্যাঁ তোমার এখনো হয়নি দেখা। দেখি বাকিগুলো, আমি জাস্ট 3টে দেখে বললাম, এই হচ্ছে ফিডব্যাক। তো আমি যেটা কি তোমার রেপ্লিকা একটা আনসার কি স্ক্রিপ্ট করে দেবো, যে এই আনসারটা কিভাবে করতে হয়? আমি তো তোমাদের আনসার যারা করতো প্রত্যেকটা পাঠিয়ে দিতাম এবং চেক করতে বলতাম, সেটা কি তোমরা চেক করতে আদৌ? হ্যাঁ, তাহলে মোটামুটি তো বুঝে যাওয়ার কথা কে কি কি লিখছে আর কেন নাম্বার বেশি দিয়েছি, আর একটা জায়গায় কেন বেশি দিয়েছি, তোমাকে কেন কম দিলাম, মার্কসটা বোঝা উচিত ছিল। বাট আমি মনে করছি যে এখনো স্টিল আসছে না, তার মানে আমাকে, দেখি বাকি খাতা দেখলে বুঝতে পারবো। আমার মনে হলো 3টে খাতা দেখে এখনো স্টিল মিসিং সাম পয়েন্টস। তো আমার মনে হয় একটা আহ, আমার আনসার স্ক্রিপ্ট একটা পাঠিয়ে দেবো এবং সেটা দেখো কিভাবে আনসার লিখতে হয়, এটারই উপরে আমি আনসার স্ক্রিপ্ট তৈরি করে পাঠিয়ে দেবো। ঠিক আছে, অনেকেই অ্যাসিডোফিলাস মিল্ক আর বাটার মিল্কের মধ্যে ডিফারেন্স করতে পারেন, কেন করতে পারেনি আমি বুঝলাম না। অনেক রিজন, অনেক পয়েন্ট আসছে, ম্যানুফ্যাকচারিং স্টেপ থেকে অনেকগুলো পয়েন্ট চলে আসবে। তারপর তো টেস্ট টেস্ট আছে, আরে টেস্ট গুলো এগুলো তো অনেক তোমার পরের পয়েন্ট। মেন দেখো কোন মাইক্রোবস ইউজ হচ্ছে, কি র ম্যাটেরিয়াল ইউজ হচ্ছে, দেন তোমার ম্যানুফ্যাকচারিং স্টেপে কোনো তোমার এক্সট্রা স্টেপ ছিল যেটা ইউনিক স্টেপ ইন অ্যাসিডোফিলাস আর বাটার মিল্ক, সেগুলো চেক করতে হবে, তো সেগুলো ডিফারেন্স পয়েন্টে ঢুকতে হবে। আর ডিফারেন্স তুমি যখন করছো তখন লেফট হ্যান্ড আর রাইট হ্যান্ড সেটা তো কম্বিনেশনে রাখতে হবে, মানে কোঅর্ডিনেট রাখতে হবে। এখানে তুমি পয়েন্ট লিখছো অর্গানিজম আর ওখানে তুমি পয়েন্ট লিখছো টেম্পারেচার, তো দুটো কম্বাইনে কি করে হচ্ছে ডিফারেন্স? ডিফারেন্স তো হচ্ছে না। তুমি অ্যাসিডোফিলাস মিল্কের টেম্পারেচার দিয়ে পয়েন্ট লেখো, and that temperature point should be included in different way buttermilk, different temperature, but তুমি টেম্পারেচার পয়েন্ট এখানে লিখছো ওখানে লিখছো অর্গানিজম, তাহলে আমি কিভাবে কোঅর্ডিনেট করে নাম্বার দেবো? ডিফারেন্স মানে কি, এখানে ইউজ হয় এখানে ইউজ হয় না, মানে এইভাবে একটা ডিফারেন্স। হ্যাঁ অবভিয়াসলি ওরকম ভাবে তো আর পাবে না যে ক্লাস 11-12 লেভেলে ক্লিয়ার ডিফারেন্স গুলো তুলে তুলে দিচ্ছে। এখানে একটু ডিফারেন্ট ওয়েতে দিচ্ছে, তোমাকে একটু মাথা খাটালে আনসার পাওয়া যাবে, 3-4টে ডিফারেন্স পাওয়া যাবে। তো ঠিক আছে, আমি এটার পুরো স্ক্রিপ্ট বানিয়ে তোমাদের আপলোড করে দেবো এবং দেখবে কিভাবে আনসার লিখতে হবে একটা 2 মার্কসের জন্য। অলরেডি বলেছি অনেকবার অ্যাপ্রোচিং কি থাকবে কি হবে, আরো খাতা দেখলে ক্লিয়ার হবে। ঠিক আছে, এন্ড করবো ক্লাস। এনি কোশ্চেন, এনি ডাউট?
নো স্যার।
ওকে।